This project and Engineering Open House are sponsored by ExxonMobil.
Hello, my name is Benjamin Chiavini, and today we're going to be talking about water acidification. So, the reason why we're talking about this is with climate change, we can see that the oceans are becoming more acidic. And so, we want to see the effects of that. So today, we're going to be talking about chloral bleaching. And to represent coral, we have our sponge. And so what we're going to do is we're going to put this sponge into our solution. Now, the solution is just water. All of these are just water despite the color. But what we're going to do is add dry ice to each one of these. Just a small amount. And you can see that bubbles are being formed and gas is being released. The reason for that is that dry ice is the solid form of CO2, and with this CO2, it will sublime. And so what happens when CO2 sublimes is that each one of these solutions will be acidified because the CO2 is dissolving into the water, causing it to become more acidic. And so you can see we have our reference solutions here. This solution used to be a light blue, now we have a yellow. This used to be a yellow, now we have a pink. This used to be a reddish violet pink, now this is yellow. We have a purple that turned to orange, and then a blue that turned to kind of a light greenish. And so all of these changes are because we added our indicators, and they cause different colors and different color changes based on the pH of the solution. And so we'll give this a little bit of time here, but with all of these, they're becoming more acidic. They used to be at a pH of around 7, hence because they're water. But once we add our dry ice, we can see that it becomes more acidic. And so I'll get this here. You can see that it's starting to turn white already. Now, this is kind of a sped up process, obviously. The acidification of the oceans isn't as drastic as this, but you can kind of get the idea that our coral will become a little bit, lighter because it has been bleached. And so it's kind of important that we deal with this climate change so then we can, try and stop this acidification of the oceans.
Hi everyone. So we all know what plastic is, right? And so today we're going to work on making one of the first natural plastics. And to do that, I have some paper, some basic copper carbonate, and some ammonia. And so first, we're going to combine our ammonia and our copper carbonate. And so what the solution does is it acts like scissors. And this paper, right, is really something called a polymer. And that just means it's a really long chain of molecules. And what this does is it will go in and kind of chop that up. And so now that it's a blue color, we know that it's ready. And we can add some of our paper in. This is tissue paper, so it's really fine. And there we go. All right, so remember how we had a bunch of paper in this cutting solution? Well, we can see that it's all dissolved now, and it's still a liquid, but it's a lot thicker. And so the question is, we want a polymer, right? We want that nice long string. And so how do we make that from this? And the answer is acid. So right here I have some acid, and when that reacts with the ammonia in our cutting solution, that's what makes it blue, it will create a polymer. And because we want it to be really thin, kind of like string, we are going to use a syringe. And so I'm filling up my syringe, and we're putting on the needle, which I want to be careful with because it's really sharp. All right, and then we're going to put it into the acid, and there we go. And sometimes it takes a little bit to start, but ta-da! And if we wait a little bit longer, that should start to turn white. And so, really the question we want to think about is, well, why is this important? This is cool, right? But do we actually use it in real life? And it turns out the answer is we do. So This polymer is something called rayon, and rayon's a type of artificial silk. And if you look on Amazon right now, you can find bamboo silk socks, which are also made out of rayon.
Hello everyone, my name is Briana, and today we're going to be talking all about DNA. DNA is a polymer which, like we said with rayon, is a very, very long molecule. And DNA is a very important molecule because it makes up the genetic code of all life on Earth, including us humans, and including these strawberries right here. So, what we're gonna do is, because DNA is so small that you can't really see it, we're gonna do an experiment to show you what DNA actually looks like. So, we're gonna take these bag of strawberries, we're gonna pour in some dish soap because this breaks down the walls of all the cells in the strawberries. We're gonna put in some salt, which dissolves the DNA. And we're gonna put in some water just to mix the whole thing together. And then here comes the fun part. We get to squish all the strawberries. Okay, so now that we're all done squishing and we have a whole bunch of strawberry juice, we have some chunky bits left in here that we don't really want. So we're gonna pass them through this cheesecloth filter right here. Alright, so now that we've done a filter and we've gotten out all the really big squishy bits, we still have some smaller bits left in here. So we're gonna pass them through this coffee filter in here. Alright, so we finished our filtering, and now all we have left is this kind of strawberry-ish liquid. But right now, the DNA is mixed into the water. It likes being in the water because we have all the salt in there. But now we can take this isopropyl alcohol, and when we mix it in with the strawberry, the DNA doesn't like being in the isopropyl alcohol, so it's going to turn into a jelly and get out of the solution. Now we gotta mix it up.